So here it is, and it uses this DVD remote.
Nice.
So the first mode is a custom mode. It's hard to show when I'm clicking and the matrix at the same time, but you can click 1, 2, or 3, and if I click 1, it'll change. It goes into a mode where I can use up and down to change the red. You click 2, I'll do the same thing with green, and 3, we'll do it with blue. You can click clear to set it to turn off, and then you can use left and right to change animations.
Oh,
Fun.
Here's another one.
So you got a combination here of previous P2 live forum content, don't you? It looks like you have JonnyMac's IR decoder adapted, and then some RGB LED code from Christmas time. Am I right?
Yeah. This is the last animation. It's really hard to see, but what it is it's bubbles, sort of. It will fill it all with cyan, and then it'll pick a random LED to set to blue and a random LED to set it back to cyan. You can also turn it off with the power button. And if you push the enter button or the menu button in the middle, it'll beep and it'll actually save what you have. So it's saved at the bubbles now. And if I unplug it, plug it back in, it'll go back to the bubbles.
Very nice.
Super work.
yeah.
I've actually needed to change the driver for the PWM to make it so you can control the frequency without having to start it again. There's a little beeper back in there. In that hole. I 3D printed all these in poly panels. It took quite a while. I'm gonna plug it into the computer so I can show the code.
For those who haven't started a project yet, this should certainly get you going. What's the hang up now, right?
Yeah, this is fun stuff.
So here's the code. It's if you open up the terminal, it'll actually show you what mode it's on, what's saved, and it'll show the power. If it's on mode 0, which is a custom, it'll show you the values of the R, G, and B.
Wow, and so take a look. Kevin's done a good job adapting some of John's code and attributing it to him and even trying to keep some format together.
Nice.
It's a great project, Kevin. I'm really impressed.
Thank you. I've 3D printed all of these pieces, and they use snap connectors, so if something goes wrong inside, you can just snap it all apart. So they're all poly panels, so that you can separate them. And let's see the back.
Any questions for Kevin while he gets this ready?
Oh, cool.
Wow, send him some filament.
Not a question, but I appreciate all the features you put into the remote control menu system you did. I would appreciate using something like that.
Yeah, the menu system was actually based off of the sixth program from last week.
Good deal. Good use of it.
Yeah, Stephanie's got some artwork at Parallax that has some control on it as well. Well, great job, Kevin. And so if somebody would like to sponsor Kevin with a Fly Sky RC unit, I'm happy to accept your money because I'll be sending him mine. So he has one to work with next week when JonnyMac shows us how this works, because we know that he can put it to use. So great work, Kevin. Keep bringing us more inspiration.
Thank you.
Okay, I'm just switching over to the presentation now and we'll get started. Thanks everybody for joining us. May 5th today, 1 p.m. Can you believe it's been almost a year that we've been doing P2 live forums? The time goes by so quick. So pretty exciting. In some ways, a lot has occurred. Today's topic is documentation, and we have Jeff leading with Stephanie supporting him. So before we get to that, let's just talk briefly about the next couple of weeks. As mentioned a minute ago, next week, JonnyMac is going to show us how to interface this little Hollywood favorite for human to whatever you want to control. So spoke with him this morning. He's already ready to go. And I'm sure we'll be in for some fun surprises. And by the way, we're now streaming on YouTube concurrent with the Zoom. So if you don't get registered, you can just go to our YouTube channel and watch us there. In 2 weeks, we have Gavin Garner coming to talk about his use of the P2 in his mechatronics class and the trainers that he built and what he demands out of his students, which is really interesting. This will be very, very informative because he's been with us for 20 years. He learned on a basic stamp too. So look forward to that in 2 weeks. We'll try to round up some more educators to join us for that presentation. And then we'll probably take a break the last week of May. We have to do an inventory count at Parallax, and unless somebody else wants to run the P2 live forum, I know I'll be pretty busy there. Coming up in June, and we have a lot of voids here in these dates too. So if there's anything you want to talk about, just let me know. It does not have to be formal by any means. It doesn't have to be a big topic showcase like this, like we do in Hollywood, but it could just be your own style, your own speed. So just let me know if there's anything you want to be sharing. In June, the first presentation we'll have would be this one from JonnyMac, and we're just going to create and share an object for this very popular sensor, which is used a lot with the Purple Air monitoring stations, the BME 680. So get yours. We have them in stock. Trying to give you enough lead time here, so if you want to get some parts, you can do that. And then we're going to move into GPS. We need to have a P2 GPS module. And this is also our favorite, the SIM33 EAU, which we just have trouble keeping in stock. So at the moment we're out, but you can go and add yourself to the wait list if you want to pick one of those up. And we also have a click module that has the same on it, I believe. So check that out. Then moving into summertime, here's a summerish type project that I've been working on for an eternity and don't really go anywhere because of my day job. But this time I'm determined to get something done. I plan on interfacing with John's help, several objects he's written, so I can get up to speed and share something myself like Kevin has done. And I will control this boat. This is a unmanned surface vehicle that I've run on Lake Tahoe to collect some water temperature samples. And I'll use the XB to send back its location. and I'll interface GPS module, and then I'll keep it under radio control too. So look for that. And I've seen a lot of action on the P2 forums online around this particular project, and you're looking at an in-progress cube that someone has printed up, and they've got the panels, and we now have these panels in stock. And the page is up, so you can order them. We buy them 100 at a time. So thanks, Stephen, for getting us going here, by the way.
Still working on it.
Yeah, your bug hunts are amazing. The forum thread is just exploding as people are trying to use the code now.
In case you're wondering, the red and the amber should not be on top of each other right there on that top surface.
This is
We'll
in
get
progress.
that worked out.
Yeah, it's looking great, and we're doing big things here.
It's
And also,
amazing. Yeah, go ahead.
I don't know if Team UK is around today or not, but oh, I see one of them. Just checking in to see if we can actually put some of these boards into production with some cool video game arcade cases that Coley's making. You don't have to pipe in now, Baggers or Coley, if you're here, but
Yep,
just
I'm here.
okay. How's
Just
Coley
got up.
doing with this?
He's doing well. The actual cab is looking really good. But I think he's been a bit run down with work, and he had the his second jab the other day, so well, about 2 weeks ago. So that might have helped with him being run down. So he's just going to have a couple of days off for the moment.
Good.
And let's see if I can find any of the pictures he has sent.
And yeah, I'll stop share when you're ready. Just tell me.
Yep.
And there's no schedule for this either, as you guys know.
Yep.
Parallax is not one to set schedules ourselves.
No worries.
Okay, so when you have that ready, just holler. And the hoverboard motors. So Chip spoke about these a few weeks ago, and we've preemptively ordered 100 units. So these are coming, and we're building a bearing block to hold them. So maybe the hardware and the motors and the electronics will all converge, and we'll have a new robot drive control system, a modernized version. These have been very popular through Parallax in the past, not this particular wheel, but our motor mountain wheel kit for mid-size robots. So we're looking forward to having what we all think will be just the best system possible.
Does this mean we're on our way to a possible two-wheeled self-balancing?
Certainly in the cards here, yep. Would not have been easy to do with the previous motor, the encoder resolution and all the slop.
How fun.
And if you spend money right now, you get a silly string trap kit from Parallax, any order over $150. And what's in here that's cool? Well, you'll get a couple cans of this goofy string, and you'll get a laser ping sensor and a servo. And the parts if you want to put it together, or you can just repurpose this any way you want. Oh, and the Eternal cable, which we're still waiting for, so we could drive servos from the JonnyMac from high current USB, is finally coming, we've been told. Okay,
I've got
so
the X ready if you.
oh, okay, great. I'll stop
Right.
share.
Okay.
All to you. Good attendance today, by the way. Everyone's interested in something.
Right, can you see that?
Oh, yeah.
Nice.
Yeah. That's a CAD 3D render.
That looks
That's
cool.
roughly what it'll look like.
Yeah, that looks great.
Oh. Press the wrong button. And that's the way. You've got the marquee up there, which we'll be able to have plexiglass or something so you can put an image on top of it. And this is just to help with the to support the joystick, so when you're waggling it, it won't rock too much. But it's nice and sturdy. And as you can see, it's taking shape. I have got that's one of his first laser cuts with it.
So we're looking at Baltic birch, like maybe what we'd call 1/8 inch.
Yeah, this one is going to be the single unit because it's got 8 buttons and a joystick. So, you know, for when we do more arcade games. I have been working on a Z80 emulator as well. I've got, I think there's one bug in it somewhere in one of the instructions, but a few of the games work. I've got my Pac-Manic Miner. Oh, it's my dog. Sorry, someone's walked outside. Walked past outside. Oi! Oi! Out of there! It's in the window. I'm not close the door. Right. So yeah, I've got one instruction that I need to fix, and then I should be able to start making some Z80 arcade games like Pac-Man and Galaxians and stuff like that. But yeah.
You have that artwork handy too. Maybe some people would like to see that who've not.
Anyone?
The artwork?
Oh, that goes in the cabinet.
Hang on the cabinet?
Yes.
Not yet, no.
Okay, it's really neat. Well, we'll show it at a future time.
Hey, what's the state of the Z80 emulation? I think I saw some talk on the forum about that.
Where's the Z80 is, well, the one on the forum's a different one, I think. Someone else is doing that one. But the one I'm doing is really close. I think I'm one instruction wrong somewhere. I think it's probably a flag or something, but it's like about 1700 instructions to emulate. So
how big did it wind up being?
It's not that much over a cog. There's just a little bit of stuff outside the cog that's running, and the other bit of stuff outside the cog is the pointers to all the instructions. But yeah, other than that, it's doing well.
I'm forgetting, did you use XByte on that?
No, I didn't. The reason I didn't use XByte on that one was because it'd probably speed it up, but with it being Z80 and thinking ahead, because I know a lot of the games and how they work, the bank memory in, so I needed to have access to the read and write of the RAM, or some of the arcade games have to be able to read a 1K chunk all from the same byte, like a joystick port or something, but it can address any area in 16K. So I wanted to be able to call a function to read a byte from RAM or to write a byte to RAM.
With some filtration.
Yeah. So it'd have been, you could do it with Xcode, but you'd have to work around it because the call will cancel the byte skip, won't it, as well? So.
Okay.
Yeah.
Thanks, Jim. And
No
wanted to be sure these two guys had a chance to talk because Jim is staying up very late with a dog that's going to wake up the rest of his house.
That's not my dog. That
Your washing machine walking away.
No, that's not here. That's somewhere else.
Okay, just a minute. I'll mute the offending appliance.
Yeah, not me.
Okay, I found it. Thanks,
Okay.
everybody. All right. So today we'll turn this over to Jeff. Those of you who don't know Jeff's been with Parallax, I think, since 1996. And he came in the office. How long, Jeff?
Yeah, that's correct. 1996. I came in the office in 95 to buy a Basic Stamp 2.
Yeah, and then
Basic Stamp 1.
you were turned into tech support and then you never left. And
That's
so now all of our software is created by you, just about, and so much documentation too. So Jeff is going to share where he is with documentation and what we're doing as a company. And he's joined also by Stephanie. And Stephanie's been with us at least 15 years, I think, and as product and documentation manager. She's our editor. She's a question generator, solution provider, and makes us look good. And she's been keeping the weekly meetings going too for our documentation team so that we can have these reports. So Jeff, over to you.
Okay. Hello, everybody. Thank you for joining us today. I'm happy to be here and happy to have something to share with you. It's been a while. Uh-oh, I just clicked away from my Zoom view. I'm going to start sharing my screen here. Looks like the right one. Okay, everybody should see our agenda for today.
Yep.
So what I'm going to do is talk about what we're doing, kind of paint a little picture of behind the scenes, followed by the releases that we're going to release today, or that we have released just before the meeting, and where to find those. Discuss some participation points for all of you, and talk about some future releases and our distribution plans, or like the format of those plans. So to begin with, back in, I think it was early March, maybe late February, we really, let's see, it was Stephanie, Michael, and I really seriously got going talking about, well, kind of discussing and digesting the documentation, the core documentation that that Chip provided, and also where we need to be. And of course, we had an example with the Propeller 1, but we wanted to not necessarily follow exactly the same recipe if we find something better. So there were plenty of discussions about that, and we started, I started going through, actually, I guess all of us started going through a copy of Chip's Silicon doc and kind of trying to get our minds around it. There's a lot of material there, and it becomes kind of difficult to get to the, the 10,000 foot view of it all, to figure out how to organize things, to, make other documents like a data sheet and a Propeller manual. So that's one of my big tasks. And at around the same time, Chip and Michael began extensively testing the Propeller 2 under various strains, current, voltage, and temperature. And that was really important because we needed, of course, to have a lot of that data for the data sheet, so that everybody can see just how far they can go with the Propeller in actual practical applications. And so what we did with that is initially we actually created the spec sheet, which many of you have probably seen. You can get it from, let's see here. If you go to our main website, Propeller 2 documentation, there's the spec sheet right here that you can download. And it looks like this. And that was intended to be a single page, which that's what it ended up being, a single page document that is, just a really good introduction level view for anybody not familiar with the Propeller. So it's what we expect a lot of people to look at initially when they're maybe reviewing or checking out a number of other devices from various distributors. So some of that test data that was done was instrumental in producing this document, because we had to make sure that we got those figures correct. Okay, so then let's see, where did I leave off? So then they continued working on that data for the data sheet, or working on those tests. And meanwhile, I switched over to working on creating the Propeller manual. Hold on a second, one of my, trying to get this thing slid out of my way. The zoom controls tend to get in the way sometimes. Okay, so here's just a quick, this isn't really the point of this meeting, but I just wanted to show you that I started working on kind of the skeleton of the Propeller manual from some of the data that was from CHIP's documentation. This is something that we intend to release starting in June with a number of further releases after that. And along the way, started asking CHIP a lot of questions, things that I couldn't find in the core documentation. So it was very productive, and then naturally led into creating the data sheet. And you can see here, this is where I left off, where I started categorizing the various spin2 commands, getting ready to work on the spin2 language reference. Okay, and so most recently what we've been working on is the Propeller data sheet, the Propeller 2 data sheet. So just to give you an idea here, remember I showed you the spec sheet, that's just a single page document. The data sheet we view as a kind of a stepping stone into even deeper material. So we intend the spec sheet's just a single page, the data sheet should be, a few dozen pages, and then the P2 manual itself, there's so much material to cover, so many features of the P2, I'm really predicting it's going to be 600 pages plus. The P1 manual, I believe, is just short of 400 pages, and that's with an index. I think we'll easily hit like 600, and I'm not trying to make it that big. It's just there's a lot to say and a lot of detail to discover and experiment with and demonstrate along the way. So today, what we have is the data sheet that we released, the very first version of it here in PDF form. You can get to it from that same Propeller 2 documentation page. It's available in PDF form, looks like this. And this is, by no means complete. It's just the first edition. We'll be releasing doing many updates here over the next couple of months. But I'll just point out a couple of things in here that are kind of nice. So there's the large pinout diagram, and then a couple of examples of connection diagrams to give people a good idea about, just what it takes to get this propeller going. So some minimal connections, and we have Michael to thank for the diagrams. By the way, he's been working really hard on those. And then here's with a single boot memory, and then a dual boot memory. And at the bottom of each of these, it describes what, some of the things that you need to know or make sure are connected properly to make that happen. Okay, and I'm actually going to switch over, I think up, I forget where it is, maybe Stephanie can jump in here, but there's, in the document, I believe that there's a link to a live document, but it's also on this community page right down here, or excuse me, this documentation page right down here. So I'm gonna go ahead and open that up. This is the document that everybody can comment on, the current P2 data sheet. So we encourage everybody to come in here and, note things that I know that there's a lot of material that we've left out currently. So don't focus on that so much, but focus on what is there. And if there's something wrong or maybe misleading or you don't quite understand it, those are the kinds of things that we want to know at this point. Later on, when it gets closer to June, if you see stuff that you think is really missing, please, start beating me over the head with comments about that. I'd be happy to go through and try to address that stuff. So this is available for anybody going forward to go through and comment away. We will address those as we go. We're going to continue working on this for the the foreseeable next couple of months. I expect that there'll be many releases of PDFs here in that time, probably maybe as often as once a week. We will typically do it on a like a section by section basis. Once we feel like something, one section is complete, that's a valid release point. Okay, and at the bottom here is a huge set of tables that list all the Propeller 2 assembly instructions in categorical order. So these are all the math and logic instructions. There's another grouping down further. And if for those of you that are familiar with the documentation that Chip has available, all of these are in spreadsheet form because they just simply don't fit very well on a document like this. So I had to make some compromises to try to squish the information in here and decide what is really important for this particular document. And of course, in the Propeller 2 manual, we'll have more detail than what is described here. And then I'd like to point out at the bottom here is some more stuff that Michael's been working on, which is the electrical ratings. Some of this from the test, some of it from the design specs themselves, and there'll be more to follow than this data that is going to create some nice little graphs that will help us visualize where the boundaries are for how this thing performs in the real world. But all the test data, if you've been following the forums, has been really encouraging, I believe. I don't think there was anything that was surprising in a negative way. It was all really good news. So that's one thing that we've released today. The next is the Propeller 2 questions and answers. So this is a, let's see, do I have this up here? I think I have it in a different view. Whoops. There we go. Okay, so there's one thing that I'm always focused on as I'm looking at a complicated topic like the entire Propeller 2 as a whole, and that is various things that a lot of beginners and even experienced engineers are going to be asking. And I'd like to provide that information in a very topical fashion that is hopefully very browsable and searchable, and hopefully raises the general level of knowledge of everybody up quite quickly without pouring through an entire data sheet or manual. So that's what this questions and answers spreadsheet is like. We provided it in spreadsheet form right now so that you can comment on it for one thing, because it's a shared spreadsheet. You can go in here and just right click anything and comment on something that you think might be wrong or may need some more information, or if you have some other ideas to share. You can also do things like click up here on the column and sort by a different sort pattern so that you can kind of get a different view. So there's quite a lot of material here, and there's way more that I have kind of sitting in the wings that I'm going to be putting here probably by the end of this week. So check back, and it's all been written with the Propeller 2 in mind specifically. Some of it applies to both propellers, of course, some of the more general topics. And some of this material actually came from the Propeller 1. I will show you some, like this is how we presented it in the help, can everybody see the online help screen here? There's this little questions and answers section, and you can kind of step through here and just pick something that's of interest to you. And this is what I mean by the topical nature of all these little knowledge bits to give you a better feel for how the Propeller works and what kinds of things you could do with it. So there are real simple questions and some more advanced things. And even I think I have some little tips interjected in here. So we'd like to provide the same kind of thing for the Propeller 2 going forward, ultimately, and hopefully some kind of form like this that's available on the web that anybody can step through. And for now, what we are hoping is that everybody steps in here and reads through all this stuff, and then suggest things for us that we don't include. So for example, you could go to the bottom, like somebody here already put something. Here's another question: is the P2 RoHS compliant? So you can just go on a blank column or excuse me, a blank cell, and just right click here, enter some comment about a different idea, or maybe even a whole category of questions that you would like to see answered here. Okay, so those two things are available right now, the data sheet and the questions and answers. And then, in addition to the commenting, which by the way, that's preferred that you live comment on the P2 data sheet and the questions and answers document. If there's something that's that's not really conducive to, or you want to provide some extra materials for consideration, you can email editor@parallax.com. But for little stuff, things that are easy to put in those comments, we'd much prefer it there, because then it's right in the right place of the document that you're talking about, and it's easy for us to get notified and go check it out. And then for the future, we have, so the data sheet we expect to be updating quite frequently over the next couple of months, probably sort of winding down around the end of June, early part of July, stabilizing, I mean. And at the same time, we're building up the P2 manual, which that will be the first release you will see, will hopefully be the first week of June. That's what I'm planning. And I think that's what Ken has planned for me too. So I'm really trying to stick to it. And the P2 questions and answers, I put May through June here. That's probably just kind of a stability period, but it could really go on and on. We could make a whole database of nice little knowledge bits about the P2, which would be really handy for people to jump into early on, or even after they've been using the P2 for a while. And then ultimately, our distribution plans are to make this stuff available in PDF form. I don't know about the Q&A, that really doesn't fit. It's not super conducive in a PDF form, but in either case, these materials will always be browsable and hopefully searchable and very topic-based on our web. My dream is that every little bit of information that's in any of these documents is easily findable, through just some Google searches or a targeted search from our website, or a link that you follow from one of the Propeller development systems. Okay, so let's see. That's about it. Does anybody have any questions for me?
For questions, Jeff, can you show us again where to get the documents for those who joined late?
Yes, so let's see, we go to the main Parallax site here. And right up at the top, there's a menu with Propeller on the left side. You go down to Propeller 2. Whoops, hopefully you do it better than I. And then over to documentation. So this page that you see right here is bound to change quite a lot over the next few weeks. Right up at the top are downloads for the data sheet, which you can, if you click on this, it'll give you a description of what it is and then give you download links there, or you can click just download right here at this point. There's also the spec sheet, and then we've moved this quick bites up to the top because that's a great resource to look at. In fact, I think that's getting so big that we need to start categorizing some things. So we're going to be working on that. And then what we have under the community documentation is things from us and from, John Titus. These two documents about Smart Pin and Send, along with the 3 core documents that Chip provided, are what is being, that's the focus of what's being considered for the data sheet and the Propeller manual content. But I have actually been looking at some other materials that people have discovered themselves, or filled with information that they've discovered themselves and provided on the forums. So again, Propeller 2 documentation is the place you want to go. And again, that live link for the Q&A and the Propeller data sheet are right here at the top of this community documentation section. And I think there's a link to the data sheet in the downloadable form, the PDF form of the data sheet as well. That was something that changed just this morning. That's why it's a little fuzzy in my head about exactly where it is. Any other questions? I don't have the chat.
Yeah, let's get some comments, questions for Jeff of all kinds. Like what people might be expecting that they're not receiving, or sorry about that. Any kinds of questions or comments for Jeff, you can ask them or put them in the chat.
Jeff, once you have the manual going, are you expecting that to be a public thing too as you make progress on it? And then PDF releases?
Yes, I do. We will make that a live document as well as a PDF, just like we did with the data sheet, so that people can continue, reviewing it while we're continuing to write it. And we'll have, I don't know, I'm expecting that to continue through July for all the intense work on it. I welcome comments from people, and hopefully we can make something that is just as helpful or better than the P1 manual.
This is fun to see, Jeff. You're making progress. It's exciting.
Thanks. Yeah, it's funny how it goes, because I end up learning a lot whenever I do this. I think they say that best way to learn something is to try to teach it, and that's definitely holds true here. There's a lot of material in the P1 documentation that I had no idea would ever be there, but it was some little caveat or an interesting behavior that I noticed, and then explored it and then wrote about it.
Yeah, Jeff, I got a question for you. Is tacos going to be mentioned or covered in the documentation?
That's a good point. Yeah, I think we should talk about that. So I think the answer is yes. That's a good, in fact, I'm going to write that down because
there's, along those same lines, I was starting to think of as you first get your P2 hardware, there's this effort of getting the base hardware. What do you have once you have the base hardware? And you kind of have the fourth built in. All you need is a terminal. Then you start adding things like the Propeller tool. And now you have additional language you can work with. Then you add external compilers, and now you even have further languages. And so maybe there's almost a timeline aspect to the introduction of,
Yeah,
as you add these things, these are the capabilities you have, these things being tools.
that's a good idea. And that really goes along with, you know, the start of the data sheet or the manual where it's kind of introducing things a little bit at a time, including a minimal connection diagram, which, you know, most people aren't going to do themselves because the chip itself is hard to manually solder. But at least it gives you a good concept of this is all it takes. And then here's the next step. And then here's an optional step. So that's a good idea. I like that, you know, talking about here's what you have right out of the box, and then moving forward, stepping into additional software. So I don't expect that we'll ever get to the point where we could cover the plethora of development tools that are out there. We certainly want to point people to it because we love the Propeller community and how everybody, you know, gets together and creates neat things, and we never want to hide that stuff, right? But you know, I think if we focus on what is built into the Propeller and built into the parallax environment for the Propeller, and then also talk about, or at least introducing people to all those the other compilers and the other IDEs, the VSC work that you've done, I think that makes for a well-rounded, you know, set of documentation. And there's plenty of other resources out there, you know, to dive deeper into those topics as well.
Yeah, Jeff, there is a comprehensive write-up on tacos with the P2, and it's called the Bit Basher's Guide to Parallax P2, and the author is Bob Edwards. And I got it off of the Google Docs somewhere. I don't have an email or the URL for it, but that's pretty comprehensive.
I'll look for that. I've probably seen that. It sounds familiar. Because when we were originally testing the P2 engineering samples, I needed to you know, twiddle some move some pin signals around, and it was nice to be able to just jump into something. I think I just searched for it on the net and found some tacos information, and did it from there.
Yeah, you might just be able to cut and paste this into the manual. I mean, it's that well written.
Oh, good. All right.
You know, after you get authorization from the author.
Ken, are there any comments in the chat window I should address?
Some positive feedback for the data sheet.
Good.
And to maybe harvest the tricks and traps thread.
Ah, okay. There's something here I see from John McPhalen about printing it. So yes, we have heard you and others that say that they really want a printed manual, and I completely understand it. I'm in the same camp where it's nice to have a printed manual in front of me. Anymore these days, I tend to do a lot of searching online, find little bits of information, and then I dive into stuff that way. So I don't have manuals very often, but we wanted to be sensitive to that. So I actually did a lot of work trying to make sure that we don't encroach on 3-hole punches that John mentioned here, because people will be likely printing out sections of the manual or maybe the whole thing and binding it themselves in a binder. And so I looked at all the 3-hole punch specs around the world. Believe it or not, there's a lot of them, and kind of came up with a you know, the Extrema to figure out, okay, so how far can we go to the edge? How thin can we make the margins without likely causing text to be cut off when somebody punches it. So we are keeping that in mind and formatted things so that that should work pretty well. Did you say there was another one, Ken?
Not particularly. I think just the tricks and traps. And I think too, from the community, is this what you expect from us? Let us know. And I'd like to point out too, to get updates, subscribe to the newsletter. So if you don't go to the website, we can let you know that way. And the newsletter is a primary tool that I use for communicating, and then the forums, which are also important, I go to second when there's time. But I think the community will see updates and they can share with each other.
Yeah.
That'll help us a lot.
Somebody mentioned because it might be a 600+ page monster of a document, a 3-inch left side margin would be nice. Totally understand that. Needed a big binder. We can't do a 3-inch margin. We'll have very little space in the document to show what we want to show, but because the document will remain live for the foreseeable future, you will be able to, make a copy yourself and then adjust that left margin before you print for whatever size that you need. It might bump things around a little bit, but hopefully things will flow well onto additional pages for you, and then rebuild the TOC. That reminds me that so we do intend to release, do multiple releases, updates for the P2 datasheet in the immediate future, and the P2 manual shortly after that. So how, when you get one of these updates, let's say that you're focused on the PDF, how do you go about figuring out what we've changed? So I did some experiments and found that if you get a good file difference engine like Beyond Compare or Araxis Merge are the two that that I know about or have used personally. Both of them support opening up PDFs, and it will show you the textual differences. It won't show you the graphics, but it'll show you the textual changes that have happened between two versions of a file, or even 3 versions of a file. You can do a 3-version compare. So if somebody really wants to go that far, it's actually really quite easy to see, oh, they changed this figure here, they changed this sentence there between last week's PDF and this week's PDF. That way you can kind of follow along as we go, because I imagine we'll be making hundreds of changes,
I was
enhancements along the way.
talking to myself. Have you experimented with change bars in the document along the margin or something? Does Google Docs support that?
I don't know if it supports that. It does certainly show in the live document. You can go back to previous versions, but unless we do a named version, it can get very busy.
Yeah, of course.
Daily changes, hourly changes show up in there, even more granular than that.
Right, just the change bar concept, something along the left margin.
Yeah, you're talking about like a little blue or red line or something that indicates something changed here.
Yeah, if that were feasible, that would be useful. The diffs are going to be, I do diffs routinely for large code bases, and it's a lot less fun than you might think pulling up a diff for doing documents and trying to find out what changed.
Yes, no, I agree with you.
Yeah, so, but if it's the only thing we have, we'll be okay using it.
But it might, I guess my point there is, there might be whole sections that have not been touched between 2 versions that you're looking at, and then a whole new section or another section that's been heavily revised, and it would at least point you to the right area, and then you can just go read through the actual document in that, those few paragraphs or that section, and hopefully find some rewarding changes there.
With respect to your large sections change, Another thing you could do if you were willing or interested would be kind of a change log annex, and then
Yeah.
annotate the big changes back there with links back to the pages. And that would be useful as well.
Yes, I believe we are going to do that. Stephanie and I were talking about that this morning before today's release. So right at the end of the document, there'll be, kind of an overview of what seriously changed here. Not hitting every little tiny point, grammatical issues and stuff. That's neither here nor there. But the real point of it, I think we will do it. Stephanie says Google Docs does not support that side margin change notification that she knows of.
Yeah, I was just looking for that too, and it's difficult. Nice. Thank you, Stephanie.
Thanks, Jeff, for taking charge of this and mobilizing and being part of the team, and Stephanie for keeping this going and outputting everything and proofing it and making sense out of it.
Yes, and I'd like to thank Stephanie and Michael for their contributions too, because I really couldn't do it without their support. I don't know if anybody else has written documentation, but going back and forth between trying to write understandable sentences and then build diagrams or focus on grammar is just a little too much for my head. I have to, it's nice to be able to delegate that stuff, and each of them tend to look at things from different perspectives, and they've definitely pointed out some things to me that this section doesn't seem to belong here. Should we put it somewhere else? And that starts some lively discussions, or maybe just a quick change. Oh yeah, you're right. So it's great to have a good team to do this, and I really see the Propeller community as part of our team too, going forward with this, because we don't always know what you want to know. So we're really looking for those points that you would like to find out, stuff that you haven't found in the existing documentation, or questions that come up from the different perspective on the P2 that you read from my writing in the data sheet or the manual. That's bound to happen. Go ahead and share it with us.
And Jeff, we'll do our best to allow you to work in some isolation and freedom without disruption.
Thanks.
We know that's important, so feel free to turn off your email.
That's very difficult to do. I could push it aside for a few hours. Otherwise it gets out of hand. But yeah, thanks. Okay, so I think that's it for me.
Yeah.
Let me check the last few
Thanks, Jeff.
comments
That's
here.
looking super good. And Stephanie and Michael.
You're welcome. And be prepared for a lot more deep questions from me very soon.
Just send them over.
It's quite a way to learn how to document something, isn't it? One
It
guy
is.
in the team creates something, and then you get to learn about it in pieces.
Yeah, well, it sure would be a different story if Chip hadn't written that core doc, though. I'd be really lost. I wouldn't know what I was looking at. So that's been a tremendous help. And I've pointed out some things to him that I think that he didn't realize wasn't documented. Because something he wrote, brought up an idea of mine, and I went looking for it, couldn't find it, and so told him about it, and then he puts that in his core doc.
It would be really neat if we matured the documentation enough so that by March of next year, we can make a printed version handout to people that come to Parallax for an unannounced special event.
That would be nice.
We'll have to talk to Stephanie about that at some point. So
Are you talking of the manual itself? That might put people over their baggage limit weight getting home.
Oh, you're right. And shipping costs have become very high too.
Yes.
That's why we offer free delivery for people that walk up to the door.
Of a memory stick.
Memory stick.
Okay, so as we move
All right, thank you,
into,
everybody.
thanks Jeff and Stephanie and Michael. So now we can go wherever we want to with our P2 Live forum. Before we do that, though, I thought I'd just take an inventory to see if there are any topics of importance to people to be discussed today. And if any, support issues, I think Chip was going to talk about how we finalize the P2 Edge revisions.
Michael is here, I think. I don't know if his eyes are still open. It's like midnight for him.
We shouldn't expect anything of him. He's in Eastern European time zone, so he's probably horizontal by now.
But he's logged on to the meeting though.
I'm floating around,
There he is.
shoving some traces left and right.
They'll need reshoving in the morning.
Oh, well, maybe not if we don't talk later.
You guys are being cut off from communicating because the bomb is entered and parts are ordered.
Yeah. Oh, that's true. Yeah.
Well, do you want to talk about P2 Edge then, Chip and Michael, generally, or in any detail? Or
Yeah, Michael's got all the latest stuff.
Yeah, I could show you the. I could do a screen share real quick if there's any interest in that. All right, let me just. Yep. Ken, if you could talk for a minute, and I'll just render this.
Sure. While Michael gets set up, I just want to thank an anonymous donor out there who sponsored a Skyfly transmitter to be sent to Kevin. So I've arranged that with Amazon here in the background. Thanks, and I'll let you know how I could take your money.
May I ask a simple question? What do you mean by P2 Edge? I've always been confused by what people mean. And I read a lot of technical documentation. What exactly is meant by Edge?
We're referring to the P2 Edge as our module.
Yeah, this thing.
Oh,
here.
it's a printed circuit board.
Yeah.
Okay.
And it could be called a card.
Got it.
But it's used, maybe the Edge connector is where it got the Edge
Oh,
name.
okay. Good. I like Edge connectors. Yes.
So, and since you asked, we have several types of connectors with the hope that people design this into their products. We have a connector that's vertical and one that's horizontal. I think that's it. Yeah, we have two different types of connectors. So most common use would be on the JonnyMac board, this board, which we call, it's part number 64020. And there's also a mini breakout board that can hold it. And then a prototype board.
Thank you.
Yeah, you're welcome.
And the P2 Arcade.
And the P2 Arcade, yeah. So we're seeing it being used in several form factors. And what Chip and Michael are talking about are some revisions that we're making to it. So we're making a revision C of the P2 Edge. And then following that, we're making a version with RAM.
Yeah, we run it through a couple different iterations because we find things that could use improvement. In this next one, it's going to be like a 5 to 16 volt input range for the power. And it will also have a 1/2 part per million accurate clock.
Oh.
Chip, you'd mentioned that really precise clock last week. Will you actually get that 1/2 part per million at the actual CPU clock speed? Or is that just at the low frequency that it's going in at?
Well, at the 20 megahertz output, it's that accurate, but because the phase lock loop is phase lock, it doesn't like go, it's going to run at some multiple, how would you say, like a multiple and a division of the speed. So of the 20 megahertz. So you're not going to like, it's not going to like add clocks ever. It's going to be phase locked to what the 20 meg super accurate time base outputs.
What I was thinking though is if the 20 megahertz is plus or minus 500 parts per billion, 300 megahertz would be, say, 15 times worse, wouldn't it?
No, because it's still a ratio.
Okay.
Yeah, it's a kind of like a percentage. It just stays the same no matter what the number is.
The other question I was wondering is, you mentioned it was expensive to get that crystal. Would you be thinking about using a standard crystal on the generic board and a special build for, say, the high-end one with a high accuracy clock?
Well, the reason we went to this thing, and it's instead of 20 cents for a crystal, I think this part's about $1.40 or so, $1.46. But we had this problem that we realized that because the XI and XO, those are the crystal oscillator pins, because they share the same V-in supply as P28 to P31, if there is some like real high speed switching, like multiple, like say all 3 or 4 pins switching at once in the same direction on those last 4 pins, it can create kind of like such a voltage spike on the internal power supplies of the chip because there's such an instantaneous current draw that if the crystal, remember that 20 megahertz crystal oscillator, I mean, when we hook a crystal up to the pins, it's creating a sine wave, right? And it's slewing very slowly. It's like 10 nanoseconds per volt. It's very slow. So what happens is if that thing is crossing the logic threshold slowly and you get one of these spikes in, the perception inside the chip is that it goes like this, boom, boom, and you get an extra clock. And that causes the PLL to go nuts and try to lock to a higher frequency, which is inconsistent. So it creates a lot of PLL noise. So the way around that is to use a very fast edge going into the XI pin. So rather than a crystal, we use an oscillator, right? Because it's going to transition in like, fully transition in like a nanosecond or 2. And that way we cross that threshold very abruptly and we can't, it's not going to perceive 2 clocks on the inside, even if it's commensurate with 4 digital IOs toggling in the same direction at the same time on P28 to P31. So I should have put in to the chip a little Schmidt trigger to input the clock. Instead I have like some series inverters. And the problem is there that we have a very fine logic threshold. And if we're slewing past it when we go from 0 to 1, and we get a big bump on the power supply, it goes like 0, 1, 0, 1, right? And that extra clock gets registered by the PLL and messes everything up.
Oh, got it.
So as long as, and then there were 2 other things. So as long as we have to go to a crystal oscillator in order to get that slew rate that we need, then we want to have something kind of low current because a 3.3 volt oscillator takes a lot of juice, like 7 milliamps, whereas a 1.8 volt takes only like 1.3 milliamps. So it's a lot less power, because you got to multiply that by the voltage too. So it was a lot, we could add a 1.8 volt oscillator for very low power cost, and for a couple dimes more, we can get a real accurate one too. So that's why we went this way. Low quiescent current, high accuracy, and high slew rate into XI. I'll say, okay, let's say Jim, who warned me we needed a Schmidt trigger on the inside of the chip. He just posted, he said the 0.5 ppm is over temperature and is true for any megahertz. There is also an absolute reflow error in the spec sheet. So after reflow, the tolerance goes to plus minus 1.5 ppm. Well, Jim, how can they advertise then 500 parts per billion? Everybody's going to have to reflow that thing, right? So no one's ever going to see this 0.5 ppm. Maybe Jim will speak up and say something about this.
So we have Michael back, Chip, and maybe we can get him to do some screen sharing.
Yep.
Okay. And Jim Granville, if you want to say anything about this, speak up. I think we've never heard Jim's voice. He's a typer.
But he's made 1 million pages of contributions on the forums. He knows the DigiKey catalog.
Yeah, I think he knows every catalog.
Did you get this part out of DigiKey?
Yes.
Could you, in the forum chat there, could you type in the just either the description or the part number?
Yeah, let me find it.
I mean, a chip, because I can go round it up while Michael's talking. In fact, we will share the whole layout, the bombs, all of these pieces with you in case you wanted to use them.
And Chip, there's another answer in chat for you from Jim.
Ah, Jim. No mic here. Okay. Yes, you need to calibrate TI. What is TI? But after that, you are 500 ppm. Then there is thermal aging of 0.5 part per million per year. Oh, okay. And Jim just put the, thanks, Jim. So he just put the link to DigiKey also up. So how do we calibrate it? Because there's no voltage input for it, right? Maybe Jim will say something about that too.
All right, Michael, what is this beauty?
I can't see what you're seeing, so let
me
know if it's
looks
let
like
me
your
know
desktop.
if the as long as the scale is good enough to see what's going on, that's all I'm worried about. Okay, so this is the this is what the upcoming Rev is going to look like, the Rev C. And I think this is the image Chip showed last week. So what we've added, the dip switches over on the left-hand side are missing from this 3D model, but they're the same as the existing Edge model. But we've got new power supplies here that accept a wider voltage range, something like 5 to 15 volts. The SD card at the top here is new, so there's an SD card socket there. And the new crystal that Chip's talking about is down here on the bottom right.
Yeah, the oscillator. And see, we also, we're getting away from these, this won't focus, but these little ceramic inductors break easily. Like I just dropped this on my table when I was talking to Michael the other day, and it shipped off, probably changing its inductance. So these new inductors are molded, so they can't suffer these problems.
Yeah. So on the image I've got underneath, this is the last change that we made, which triggered me going back to my prior version, which has the RAM chips on. So this will be the version with the RAM chips on that will come a little bit later. But I can actually rotate this so you can see, these molded inductors are super low profile here. So the risk of damage now is kind of zero, one would hope. But yeah, so the last thing that we are just changing is that there's 2 resistors over on the left-hand side here. I need to find a space for. They're going to be pull-ups on the TXRX lines. The existing Edge didn't have pull-ups, but we thought it's a good opportunity to include them. And on the back of the board, there is one change that may or may not suit everyone. You may recall we originally had some pads down on the bottom right-hand side for voltage in, ground, and the prop plug. But all things considered, it became quite awkward having them there. So we've dropped the separate 5-volt ground inputs on the basis that if someone really wants to solder a right angle connector onto supply power there, they could just drop one over these edge connectors anyway, because the pitch happens to be right for that. And we've moved the prop plug headers up to the top edge here. So the idea is that if somebody is in the field, let's say there's an edge module plugged into a device and an engineer wants to go out and hook on a prop plug or just touch on a prop plug whilst the edge is still running in its environment, then they could you know, engineer could potentially have a prop plug with pogo pins on the end and just press it against there and instantly have debug output or be able to reprogram flash.
Yeah, and you could use those big tool pins as guides down to the
Yeah.
pogo pins.
Yeah, absolutely.
Hey,
So,
Or you
yeah.
could put vias in those pads. If you put vias in those prop plug pads, then you'd be able to you'd have something to bite into. I do that a lot.
Yeah, that's a possibility as well. Yeah, we might be able to do that.
It would be good also if those pads, if you made a line right through the tool pads, that there was a full round, a full radius on the pad for the pogo pin, so it could be in line with the outer tool pins. Yeah.
Yeah. I'll drop it down so it's.
It might already be there. It just so the radius is you know, fully there.
Yeah, I'm sure it's not there because I literally just dumped it there to show it now. I haven't aligned it at all. So it's just roughly in position. Yeah, I think it will be aligned horizontally with the mounting holes, and then I suspect the silking will probably go on the board edge, not on that edge. And I've set the pins this way so that you could solder a right angle header downwards, so that if somebody wanted to, you know, maybe a road warrior wants to just have a P2 edge to program on the road, or I don't know, that's a bit extreme perhaps, but they could solder a right angle header pointing downwards towards the edge connector, and then the prop plug would slide in that way, and you know, you can program it that way. But the order is important for that because the prop plug will only fit one way round with the PC, you know, coming in from that angle. And then of course from the top you can plug it in either way around because of the it's air there. So yeah, so that was the change. I don't believe we've changed anything else.
Well, you've changed the cost of building it.
Well, there is that. Yeah.
Just having fun with you guys.
Added a few dollars to the BOM. Yeah. You'll have to consider the unit price once these come off the line. So that SD card socket, that launches a new necessity for a driver. Yep. Yeah, I know a few people have their hopes on chip writing one. And I think the most advanced one that I'm aware of is the one from Ray. Yeah.
You're talking about SD driver, Ken?
Yes.
Ale, the SIDCOG guy, he has been interested in doing a file system for the SD card.
That's right. In fact, you put me with him at one point. I need to follow up on that. Anyway, so here's the just before I go, here's the dip trace view, which is always interesting. So we've got this down to 4 layers now. I think that's been mentioned. So we've got the important thing is that we've got all the power, all the high current power at least, all on the top layer. So it's not having to go down through vias and back up again anymore. So we've got rid of all that impedance and inductance. So here's the VDD, so the 1.8 volt bus. Oof, there you go. So that's all solid straight through. And then we have the other power plane there, which is the inputs to the LDOs. Don't worry about some of these gnarly looking traces, by the way, they've just not been made nice yet. So that's the other power plane there, and then some other signals on top as well. And then layer 2 is just ground, apart from the straps across for the 3.3 volts coming out of the LDOs into the P2. I need to look at those at the end of the process to make sure we're not
crossing any planes in a nasty way, but otherwise that's all solid plane. And there's a little 1.8 volt trace there feeding into the crystal circuit. And then we'll have the core, and then layers 3 and 4. 3 being the signals. All the signals are on here. Again, don't worry about funny looking right angle traces. They're just not been routed in yet. But all the signals are all down on there. And then that'll be tightly coupled to the ground plane on the back. Yeah, and of course, actually, I haven't looked, having added that pad there, if that's going to sit across traces, but yeah, I need to make sure it's not, but we'll get to that. But yeah, so that's the stack up now.
Michael and Chip, is there any indication or thoughts on whether this new P2 Edge design will have a positive effect on that one port that we found has issues with high-speed signals?
Oh, well, yeah, because it has, you mean that caused the VCO to, or the PLL to go mad?
I don't know all the details about it. I think that there was video being run.
Yeah. And they would become jittery.
Yes.
Yeah, that was because of high-speed switching on P28 to P31. So by getting rid of the crystal, which slowed very slowly, and putting in a nice sharp, crystal oscillator with a 3.3 volt inverter, it's going to deliver nice sharp edges into XI. And so there's not going to be opportunity for these upsets anymore.
Great, thanks.
I wish I just would have put that Schmidt in there. I wonder if Ken, at some point we could talk to onsemi about doing a rev that wouldn't involve any more synthesis, but just cleaning up some stuff in the pad frame. There are some little improvements we could make to the ADCs, like the calibration resistors. And then there is this clock issue. And then there is also the latch up problem. Remember that?
Yep.
So anyway, I don't know if they'd be game. They probably want to see us sell a couple 100,000 more of these chips before they entertain that.
Chip.
Yes.
A question to you, or perhaps to Michael Mulholland. And excuse me if I spell his name awkward because my speech is terrible. About the P2 Edge adapter, that small PCB that has only the Edge connector and some other connectors around, not the JonnyMac one. I did raise it. Yes, I did raise it the question, what will happen with that board if we use other than 5 volts input into the edge, because that board relies on 5 volts coming from the edge perhaps, or something, to feed the connectors around, the pin connectors around. So if we don't have 5 volts, where should it come from?
Well, we don't have a regulator on here.
Yes. And also,
so,
I believe in JonnyMac's, we don't have a regulator in JonnyMac's board, or we have a regulator in JonnyMac's breadboard setup.
Oh, we're going to add that. Are you still there, Michael? We're going to add, in fact, to the latest one, didn't you put a 5 volt switcher on that board?
So the plan is for the JonnyMac board, the plan will be to add a 5 volt regulator of some sort, so that if somebody does connect high voltage input, then you'll still have 5 volts available. For the mini board, we have thought about it. The problem with the mini board, or the issue, is that that's the one that really wants to be as low cost as possible. And if we start adding regulators, we're just going to, you know, that's not going to work. So the current thinking is to change the silk screen labeling of the headers where it says 5 volts. We'll probably change that to something like V in.
All right, so if they want to use a 5-volt module, they're going to have to plug 5 volts into this thing.
Yeah. And what we might do is add a 2-pin header, or possibly a 3-pin header, possibly behind the barrel jack, which will enable people to enable and disable the power connection to those, so that if someone is using a 17-volt input or whatever, we haven't actually ran the final test to set the upper limit yet, but it'll be 15, 16, 17 volts, something like that. Possibly 15 volts, just to derate it a little bit. The main thing on that, just to digress on that V in range, is to get something that's over 12 volts and over the sort of typical charging voltage for 12 volts. So 15 volts might sit quite nicely, or 16. So anyway, yeah, if we put a 2-pin shunt jumper there, then people could disconnect it if they're using a high voltage in. And if they're running 5 volts, then they can just connect the jumper. So that's one way of doing it. Another possibility with that same jumper arrangement is people could take the shunt jumper off and inject 5 volts there. If they've got a header pin available, that could be a source, and then they could still use a different voltage at the barrel jack. Yeah, so there's a few options there. And we hadn't actually finalized the decision on the JonnyMac either, because that's also another possibility, is to provide, whether to go for 2 voltage inputs or stick to 1 and have a voltage regulator. So yeah, there's some things to figure out there.
For 2 capacitors and a small, like through-hole part, we could put a 5-volt LDO on there.
On where?
On this thing.
Oh no, you'll double the cost.
Yeah.
So yeah, I mean that has to be that's the low cost entry thing. Right. People, there might be 10% of the people that want that, but most people don't want to pay an extra $10. They want to get it as cheap as possible for a basic breakout. And that was the principle of the original design, was keep everything 5 volts, so it keeps the cost down for everyone. Yeah, and the same is going to be true of the JonnyMac. Adding more regulation is just going to push the price up for everyone. But
we have to do it on that one because they're going to plug in all kinds of things. Yeah, this has no components on it that are like active or passive. It only has, headers, push buttons, and connectors. That's all it's got.
Yeah. So adding regulation there just makes the thing bigger, adds, doubles the cost.
And Michael, just another thing. I believe you did posted a mock-up for that board into the threads, and I saw in the mock-up the power connector is set up in line with the edge connector, very near to the side of the connector. In the last forum meeting, I raised the question if people making plastic shields, not plastic shields, but plastic, I don't remember the name, to put around the P2 edges, will not interfere with the positioning of that plug, with that power plug by the side of the edge connector? Is there any space between the power plug you did show in your mock-up and the edge connector, or they are close together?
I suspect there's space, but I'm not clear on which board are you talking about? The breakout board.
You did post, yes, the mini breakout board. You did posted a new mock-up I believe a week ago or so, into the forums to
Oh
show
gosh.
what.
Let me check. I actually don't remember, so I'm glad you. Let me see if I can find. Well, anyway, I can answer the question. We're certainly not going to put anything so close to the connector that you won't be able to use the plastic housing that that was posted on the forum.
Okay, because I saw some plastic housings to the edge that has a protrusion of plastic involving the edge connector. So I was concerned about those plastic shields interfering with the connection, because the power connector is very close, seems to be, at least in the mock-up, seems to be very close to the edge side.
I think we would certainly have something like a 5mm gap at the two.
5 millimeter. 5 millimeter? Oh,
yeah.
no, it's good, because I believe the shields are about 1 millimeter of plastic or so. Okay, thank you. The mock-up didn't show it clearly, so that's the reason I raised that question.
Yep, no, good point. Good point.
Hey, Michael, Jim posted a link, the LCSC link. We could buy all those things for 57 cents each. And they're the package is $32.25. Is that what we're using?
I don't believe so.
3.2 by 2.5 millimeter. Or were we using a 2016 or something?
Pretty sure we're using 2520, 2.5 by 2 millimeters.
Okay. These we could buy for 57 cents each. And the ones that we're looking at are $1 more, right?
Yeah.
What's the part description for this one, Michael?
Well, it's the oscillator. Do you want me to give you the, I'll text you the part number in a minute.
I think I found it.
Parallax part number.
It's the Epson part, but this one would save us almost $1 per unit on the first, well, probably going forward forever. But they have 1,400 in stock.
Yeah, their reel is 2,000, so that's going to be a split reel, which is annoying.
I have a question of a different nature. Will the new, or are we looking towards the new layout for the P2 Edge will it afford us any better environmental test, stress test on the P2? I know that it's 4 layers instead of, what was the previous one, 6, I think. So there'll be some thermal differences that might be helpful for our heat tests, but didn't know if you had considered anything about that.
Yeah, we went over this, Michael. We were going to rate this thing for, was it 85C?
The Edge module, yeah.
Minus 40 to 85C.
Yeah, because the pricing of the clock crystals and the caps just goes silly once we start pushing to 105 even. So yeah, the Edge module is definitely going to be 85 rating, and but the P2 chip itself is rated at 105 at the moment. It's just a question of cost. If you want to have, you could build the Edge module with higher temperature rated components. It just adds, again, it's sort of adding a fair few dollars to the cost for everyone. So a customer that needed that could certainly build an Edge module version that runs at high temperatures.
Thanks.
Michael, you think it'd be good to switch to this part? It's 3.2 by 2.5. I think it's the same footprint otherwise. I mean, the pinout's the same, just bigger. But
Yeah, we'll
we cut
check
a
the
whole buck
details.
off the BOM.
Yeah, I'll go through all the details and check it. I'm just actually having a quick look to see how it fits in terms of footprint.
One thing we can never tell is the actual importing cost of these.
Oh yeah, that can blow things up.
Well, it's variable lately.
It's China as well, isn't it? So you've got the tariff.
Yeah, the reverse tariffs. I just imported 150 kilograms of servos from Taiwan, where they're made in Futaba. So 150 kg of, a fairly large person. Total cost $1,800 of freight alone. But anyway, these are little popcorn parts. So
Like a plane ticket.
It's a plane ticket, yeah, and that's not even counting the tariffs. But from China, we can count on doubling the unit cost.
Yeah, so.
And I don't know where Jim is. Maybe it's easier in New Zealand to buy there.
Yeah, well, we can buy from Taiwan pretty easily. We just have high shipping costs, right?
Yep.
But no tariff.
Right. But they will have, I don't know. I shouldn't say what the situation is.
You mean you don't know?
Well, sometimes Taiwanese have to pay, I don't think they have to pay tariffs, but we have tariffs with Taiwan too. They're just not as big.
I see.
But we'll go wherever you guys want to go here.
This is the way everything works. The price is not really the price.
Yeah, the spec is not really the spec. Nothing is what it seems.
Yeah. So availability of this, it looks like, I think a month out. That's the way it looks to me. And then,
yeah.
Okay, because PCBs are not ordered and parts are getting ready to be ordered.
Yeah, the board build time, I think, will be that'll be the slow thing.
3 weeks,
Yeah.
Yeah, even Jim pointed out on his last shipment for 4 kilograms was $90. And I assume that's to New Zealand.
No, he says US dollars 87.94.
What's the cost going to be on the new one?
Same.
Still going to be the same price?
Same price, yeah, same retail price, but our net cost goes up like $1.50, Ken. What is it?
It goes up easily by $2, but if we really factor in our NRE and then pick and place and parts we're throwing away that we're not using anymore, it really goes up by like $7.
Yeah.
So just want to be totally open. The economics of the P2 Edge are very interesting. And we all want it to be $49 for sure, but it's under threat for sure. Because just to be totally transparent, our average gross profit on is $10 per unit. It's really not a very highly sustainable effort at the moment. So maybe you can buy a lot of them, Greg. I know you already are. Thanks. And then we have the RAM version coming. We didn't discuss that yet, and that'll be next up, right?
Yeah. Yeah. And we need to figure out a pricing on that as well. So.
Yeah, I'd love a little more community feedback on P2 Edge pricing too. Just what people expect and what they would hope for. It'd be really nice if they gave us some guidance.
Well, we know what the answer is. Okay, should it be like
free.
$3 or $9?
$4.
$4. It has
That's
to be $4 now.
But provided Henrique's project and Francesco's project and everything starts taking off, we can support that. We have the volume.
Yeah, well, there's the thing is leveling out now design wise. So this is where we incur like lost costs, like parts that we used on the first rev that we bought lots of that we won't use on the future rev. That fades over time.
So when you go to your next rev, you're not going to be producing any more of your original rev?
No, this is a Rev C, so it's considered a replacement.
Didn't you make a comment last time that you had a lot of unpopulated Rev 1 boards?
I'm sure we do.
How many do you think we ordered? Didn't we build like 500 or?
Yeah, but usually that's a pretty minor expense because we plan that, we run that pretty tightly. It's the components that we have to buy in larger quantity because the price drops significantly. Like it goes down to a half or a third, as you can see.
You ever consider selling just the blanks?
The PCBs alone?
Yeah. They might make good collector items.
Oh yeah. Not so you could populate them, but just so you had one, right?
Right.
Come see us in March.
That sounds like something we could just drop in boxes.
Yeah, it is.
We like a mystery box thing. Just throw a bunch of blanks in there.
Well, you know how mystery boxes get created, right?
Yeah. Big jumbo size key fob.
Yeah.
That could be a good key fob to have the USB stick with the P2 manual on attached.
Yeah,
well, couldn't somebody take a blank and populate it themselves?
I don't know.
I have. Yeah. I've hand soldered one of them. So yeah, no reason why not.
You know, Jim Granville's cost it comes out to just about $10 per pound to receive from LCSC. But then he has no tariffs. So I think a reel of those oscillators would weigh only like probably less than half a pound, right? But there's going to be a minimum, like probably $20 or so.
Well, when you guys make the decision, we'll order and find out if you want to do that.
All right. Hey, Ken, do we have the ability to cut those arcade cabinets with our laser?
I was just thinking about that. We have a 75-watt Epilogue. We don't do well with wood, and there are a million shops that do wood very well, as I found out from working with another customer, and one shop in particular in Santa Clara that I would just send them out to have them cut up, is the answer. Wood is a little bit scary for us.
Can they do anything to control the sintering, like blow lots of air as they cut so they don't get a lot of black around the cut, or blow nitrogen or something?
I'm not sure, Chip, but we have found a shop with this other customer I'm mentioning that has come close to producing the very best quality we've seen. They're in San Jose, and they do a lot of like art, steampunk type stuff.
Oh,
so they have gears, and they're cutting with wood, and wood, this Baltic birch is difficult because it burns and it catches on fire. But to be totally honest, none of these shops that I have seen in the USA have come close to the shops in China that are using the pre-finished lacquered material in terms of quality. I could show you an example. Hang on.
I think, you know, nitrogen can be made on site. And it seems to me if there's like a nitrogen flood around the cutting laser, that you could get around this burning problem.
Yeah, this is what you can get from Asia. I don't know if you can see that or not.
Piper, yeah.
Yeah, from shop in China. Just absolutely perfect. Perfectly cut parts, no burn marks. And this has been difficult to duplicate. But I think we've just
So
about
that
got
thing,
it.
those parts don't, like, ash doesn't rub off on your fingers from the edges? Is that because it's lacquered?
I think these parts have been cleaned.
Yeah.
Someone
Yeah.
playing Minecraft, Ken?
I have been.
I have one of those too.
You do?
Yeah. Yeah.
One of my clients down here in Southern California, they build all the cabinets for Starbucks. They have 3 CNC machines, and that's all they do all day long.
So they're sheet routing plywood.
Exactly. Doing the same thing you're doing there. They'll put a sheet of plywood in there, and this thing works on it for about 10 minutes. Then they pick the sheet up, it goes over to the next one, and it gets laminated, and then it goes into the next one and it gets sanded. It's all a complete assembly line, and it's fully automated.
Wow.
But probably for what you're doing, the cost would be cost prohibitive for what you're doing there. It would be too expensive.
Hey, I got the Hall effect sensor working on this motor here yesterday, and it takes amazingly low power now. Let me see if I can turn this thing on. Okay. Let's see here. You can see this thing going. It's spinning at like, I don't know, maybe like 150 RPM or so.
Wow, so
And I've
quiet.
Oh yeah, it's amazing.
What's the
And
voltage and current, Chip?
This is the really cool part. This poor old, look, we got this from Dad. He had this thing, the meters fell into the box. But anyway, they still work. So if you can read that, I don't know, can you see that?
No, can't. There you go.
16 volts, right? But check this out. Look at the amps. Hold on.
Hardly measures.
Yeah.
What? Why don't you grab that motor and
Yeah, that's what I was going to say. How does it do? Once you
Yeah.
start
Okay,
running?
here we
Try to
go.
lock it.
Grab the motor. Let me make sure I can.
Okay, wait a minute. We don't want you to mess up your hands.
Not
No,
enough
I'm not
hands.
going to. Let me drag the supply closer. Hold on. Okay, now.
Wow.
Do you have like
here.
a
Now I'm going to put
maybe
my
a
hand
towel?
on the motor.
Is that first notch 1 amp or 5?
2 amps.
2.
Wow.
So now this control program I have is really simplistic. It's not keeping absolute track of position. So if I start to get like a whole phase off, then I have to like restart the program. But see, when I start the program, watch. And here's the funny thing about this. I can I can turn the voltage down. Oh, I turned it down too quickly. Okay, so now we're at 8 volts. See it slowing way down? I'll even go lower. I don't want to go so fast that my thing doesn't keep up and then it seizes, but so now we're at 4 volts. And so it's kind of voltage controlled because the Hall sensor tells us, like, you know, where we need to go next. And I have like a kind of like a phase lock loop in software that just tracks it. So the program just the line, the code that actually does the feedback is like 2 or 3 lines of code. It's real simple.
Nice.
So I can make this thing, let me accelerate it.
So could you set it to spin at a certain RPM, and as it gets loaded up, it will continue to spin at that RPM?
Yeah, what I would do is I would have to add some more dimension to my control program where I control power. Here's the funny thing. It's using like full power PWM to drive, but because it's hitting, I think, at like the proper 90 degrees offset, it just doesn't take much juice because it's not like rigidly holding the motor as it turns it. It's just moving it to where it needs to go next. So now I'm at 20 volts and we're only like half of an amp, but it's really cruising now. Can't really, I'm sure you can't tell in the video, but anyway.
Yeah, another thing those are good for besides driving robots is pitching tennis balls.
Yep. Although this motor, you know, it has those electromagnets out at the circumference, and I don't think it's really designed to turn that fast. It's torquey, but it's not really fast. I think it almost has to do with like the reluctance in the windings or something.
Or the fact it carries your children around.
Yeah. Yep. How do I shut this thing off? I'll just turn the power off. There we go. Anyway, using the Hall effect sensor really improved things quite a bit. In fact, here, I'll show you the code. Let me do a quick share.
So Chip, do you have enough experience now with Doug to finalize the PCB hardware and connections?
Yeah, in fact, he was working on that. Yeah, he said he was working on it last night even. Okay, so here, see, the 3500 is like the max power we could have. And up here, I make the pins. These are the pins that read the Hall effect sensor. It's on 32, 33, and 34, right? And so here I program the pull-up resistors, make them high outputs, so they're also inputs. And then I reset the state variable for the Hall effect state. And then let's see, right here, I read the Hall effect sensor. Oh, this could be totally simplified now. I had like randomly numbered pins before, so I don't need this much code. I just need to look at in B and it was 7, and I'd have what I need. But then I say, if it's changed, you know, if the Hall effect reading has changed, then output the new value to a little debug display and then update the state variable. But here's the business right here. It takes the Hall effect reading, which is one of 6 possibilities, and then it converts it to 0 through 5. Then it multiplies it by a full, you know, 1/6 of 32 bits. And then if I put, you know, -8, that could be a +2. But I was just looking around, feeling the edge, like, where is it a little bit more efficient? And as the motor turns, you can hear it a little bit. There would be actually, you know, things down like in this region, maybe this bit right here, this 8, where it kind of like makes minor improvements. But really this thing, if it's 0, it goes one way. If I make this a huge number, it goes the other way. But you can tweak that a little bit to optimize it slightly. But basically, you want to add 0 or 8,000 to it. And this could be a plus. But anyway, that gets our angle of where the Hall effect sensor says we're at, right? It takes this one of 6 combinations and then turns it to a 32-bit number. And then that will make it turn one way. This will make it turn the other. And then it determines the error against our accumulating angle. So we want to have, you could just take that straight angle that you're seeing and use it to output back to the motor, but it kind of has this aggressive high current response that's kind of grindy sounding. So what this does though, is this is like a phase lock loop. You know, this says, what's the error? The difference here, and that's going to be -1, 0, or +1. And then it basically adds that, it adds the acceleration or the speed. That's really speed, I guess. And then it adds that to the angle. And that's all it does in this loop. You could get rid of a lot of the stuff, but these 3 lines here are what do the job. But so this gives us nice looking, let me see, I'll run this thing again. Let me turn this back on. All right. Here's our, and if I turn the voltage, I'll run the voltage down. So you can see our 3 phases there. And then you can see current on the bottom 3. You guys still hear me?
Mm-hmm.
Okay. Anyway, very low current now. Oh, but you know, I could boost up that current a little bit. Let's see here. I amplified it by 6. So what you have here in the green, the logic one here, that's the reading from the Hall effect sensor. And then this is, these 3 phases are our PLL that are trying to keep up, that are keeping up with the Hall effect sensor. So by varying the voltage, I can actually change the speed, and I've set the power to a pretty high value. But it works, the dynamic with the Hall effect is much better than trying to just run it open loop, because if you're open loop, it'll hold the phase you want, but it's taking lots of power all the time. This way it's like just super low power, because you're only giving it what it needs to move, not to also hold it in position.
Wish I'd had something
see
like
here,
this in my power courses in college.
Yeah, I see it turning pretty slowly. It's running at 4 volts now. Let me even turn it down lower. 2 volts and maybe a very small amount of current. Whoops. Let me see if I can go down to 1 volt. Yeah, there's now that's just enough juice to make it go. Well, we need a little bit more. It needs like 1.5 volts. But look at that. And it's, if I try to hold on to it, yeah, the current goes up. Anyway.
That's amazing.
Yeah, there's a reason why they put that Hall effect sensor on there. It makes it work a lot better.
So Chip, is this the same motor from last meeting and you added 3 Hall effects?
Yeah. See, Doug had designed this board so they can plug in right down here.
Yeah, you're not, your graphic is still up.
Oh yeah. Okay, let me stop this. So see down here?
Yep.
I can't see. wait, there. Yeah, there's a little Hall effect connector right here. So that comes from the motor. And
So you
so
got three Hall effects. And how did you position those Hall effect sensors on the, in relationship to the coils?
well, see, they just came completely fixed. It's all part of the motor.
Oh, it's already included in the motor. Okay.
It's like one monolithic chunk. And what they did is they put them at very strategic points so that each resolves like 120 degrees of phase in the 360 loop. And so what happens is they space them apart, kind of, there are three of them like this.
Mm-hmm. Yep. And
they fire in a pattern like you saw on that green logic display. And they don't really need, I mean, I was thinking, okay, well, what I can do is I can add any arbitrary phase to that, but really just add 0. You add 0 or flip the MSB, or do nothing or flip the MSB, and you can control the motor. Because I was thinking, well, now I can add 90 degrees by adding like 4,000 hex, but they already positioned the Hall effect sensor, so you don't need to do that.
Right.
And they made it really simple.
Yeah, so I believe last time you mentioned you were getting some weird waveforms out of these sensors, recall? Or was that on the posting in the forum?
I don't remember, but at one point I had I didn't realize how Doug made this board, and I was wiring the motor into what were also along that strip of screw terminals, but it was the actual Hall effect sensors. So I was like shorting the motor windings to the Hall effect sensors, and I couldn't figure it out. And Doug came and looked at it and goes, "Oh no, the motor connects to these over here."
Hey, I'm going to put a link in the forum. I think I put it. Hold on, over here. About a guy that's has a YouTube. His name's Great Scott, and he does the motor without the Hall effect, basically sensorless. And what we were talking about before, he accomplished that with the zero crossing, but it also, he pulses, he uses the current sensor of the 3 returns, the resistor sensor that you had. That's the current flow, and there's a threshold, and when the current hits the threshold, he basically opens the high side FET. It shorts the low side FET on that coil, that one specific coil, and then fires it again like 40 microseconds later. Watch the video. He's basically at the threshold from the current sensor, and he's he's on and off at that threshold before that winding is de-energized. You know what I'm saying? So he's at the threshold. He's probably at the max capacity for torque on this motor.
Okay.
And that's a feature that we didn't mention before. And he's doing it sensorlessly, with
that's what we want to figure out, because that's ideal. Then you can run any motor without any specific. If you have a Hall effect, that's great.
Right.
But it would be good to be able to run any motor as well.
Well, now if you have a circuit working with the Hall effects, if you adopt this scheme and compare with a waveform and the efficiency, current, all that between both modes, you could say without a doubt that sensorless is doable and is comparable to a Hall effects.
Right.
Yeah. So look at that video. It's a pretty good. Part 2.
I think also, sensorless would adapt. It would home in on the ideal, because even the Hall effect isn't ideal. They manufacture it to be right, but there are still little tweaks you can make to improve it that probably vary from motor to motor. But sensorless would actually figure all that out just in process of running.
Right. Yeah, well, sensorless, you got all the information that basically a Hall effect tells you from the coil that's not energized, it's floating, and using that as a sensor, you could dial in, and either you could lag and lead that 0 point for max efficiency, you know, when you do it in the lab.
Yeah.
So in the field, you got, you know, the most efficient component there.
Yes.
So yeah, look at that video. It's quite interesting.
Yeah, thanks, Kevin. It's running on my screen now, but I'm going to watch it really carefully. And
when are these motors going to be available? The ones that Ken mentioned earlier.
Yeah, I'm just looking that up right now. So it says waiting for supplier to ship. We've paid, and they're coming air. And other than that, I don't have any other details, but I'm going to ask him now.
And your product line on your shop, there are no drivers, hardware to drive this size BLDC.
No, we had a motor controller, the DHP10, based on the Prop 1, but it was recently discontinued. So we have at the moment, the only product we're bringing back is the motor mount wheel kit, which are the 12-volt motors, but we're not providing a motor controller for it. Okay. So we're looking forward to this solution.
Yep.
And really trying to move towards these motors, move our customers this direction.
Right. Right.
These are also easier to interface in terms of a bearing block. It's just one piece. So it's like a 2-inch square by 3-inch high chunk of aluminum with 2 set screws in it on both sides. And the motor, what looks like the motor shaft, I guess if you invert the whole thinking of the way a motor works, is really where you secure the motor. So they're easy to mount.
And you'll have engineering drawings, you know, CAD or from the manufacturer.
I need to start asking for that. So I'll take this opportunity now and ask them.
You said Kenneth Glass is making this?
Yeah. We could make it though too in your shop. It doesn't really matter. So the actual motor itself, if you're interested in a link to that, I'll post it right now in the chat. And when you click on more details, the page doesn't open anymore. It used to open. So something broke.
Ken Glass is like a Harley guy. And Ken, my brother, was saying that the motor mount he made looks like something from Orange County Choppers. Stephen, you seem like a guy that would have a Harley.
Nope, never been bikes. My wife does though, has a Honda.
Yeah, there's not, oh, it says more details. You're saying that doesn't work, Ken?
Right, for me. What else would we like from the supplier since we're talking about this? Engineering drawings. Anything else?
Yeah, they typically have your, you know, an application drawing, like, you know, your typical circuit. There are, you know, components that can drive these things like that microchip component. And that's, I think, mentioned in that video that I linked to up above. But yeah, so your typical application, I think it's called.
Okay. These guys haven't been very forthcoming or useful with questions like that. And it seems like, you know, there's one guy in the neighborhood makes the circuit boards for the hoverboard, then his friend makes the motors, and they end up doing all their own specialties.
Right, it's kind of like these hoverboard motors have a recipe, and all they know is they're just selling, they make it according to the recipe, and the recipe standard, and they don't even know like what the detail of the recipe is. They just make the recipe. You can't find like any explanation of how the any explanation from these guys that I found, like what is the pinout for the Hall effect connector? You know, you just have to find that. Someone else put that up on the net. Probably from reverse engineering a hoverboard.
Exactly.
Further,
If you want the documentation, you got to go back to the US and find out who originally designed it.
And quite honestly, this company may not even be making these motors.
Right.
They might be made at a shop down the street. It's
Yeah.
you never know till you go there. And then different people join the room in the discussion, and it turns out the connections are friends and Guanji, made by Guanji. They're a very special form of relationship where I trust you, therefore you can trust my friend, and so on. So I'll ask for engineering drawings, the complete specs, and any microcontroller interfacing examples for fun. I'll hang out here for a minute or two in case we get a response before I leave, because it is morning there.
Chip, the machines you got in last week, did they hook up all right? Oh, he's on the phone.
Yeah, I can answer that. Yep, they did. Yeah, there's three-phase power brought in for a lathe and a mill. And one machine's already making parts for us.
Great.